Hello, 6th grade math students. This is Chapter 9.3, Real World Problems with Graphing. We're going to solve real-world problems involving equations and a coordinate plane. Let's begin. Angela is driving to the Raccoon River. The distance traveled, d miles, after t hours, is given by d equals 40t. Graph the relationship between d and t. Use 2 units on the horizontal axis to represent 1 hour, and 2 units on the vertical axis to represent 20 miles. The chart given here shows our first 4 relationships. If time equals 0, distance is of course 0. When time equals 1, distance is 40 miles. When time equals 2, distance is 80. When time is 3 hours, distance is 120 miles. And when time equals 4 hours, distance is 160 miles. So let's graph this on a coordinate plane. Here's our graph of Angela's data. This allows us to see what is happening in the relationship between the time traveled and the distance traveled on a graph. It gives us a visual representation of the relationship between the two numbers. This type of graph is called a linear graph or a line graph, simply because it makes a straight line. We can use the information on the graph to find out information without having to do any math. For example, in question B, we want to find out how far did Angela drive in 3.5 hours. 3.5 is not one of the times given, but by using the graph, we can figure out quite easily how far she drove in that amount of time. We simply move over to the 3.5 point on our x-axis. It's marked with a B right here. We travel up our line. We meet the line that we've graphed. And then we work our way back over to the y-axis, where we see that in 3.5 hours, Angela drove 140 miles. See how simple that was? Next, we can figure out Angela's speed. Remember back to our rates chapter, that speed equals distance divided by time. So Angela's total distance was 160 miles, and she traveled that distance in 4 hours. Therefore, her rate is 40 miles per hour. Now let's say that Angela has driven for 4 hours. If she drives another hour at this constant speed, how far will she drive in all? Okay, so distance is equal to speed times time. Angela is going to travel at 40 miles per hour for 5 hours, which would equal 200 miles. Our next question is, if Angela wants to drive at least 120 miles, how many hours will she need to drive? Express your answer in the form of an inequality in terms of t, where t stands for the number of hours. Okay, if t equals time, or the number of hours, and we want Angela to go at least 120 miles. Let's go over to our graph, find the 120. Let's go over here to meet our line, travel down that point to a time, and it looks like she needs to drive at least 3 hours. So t is going to be greater than or equal to 3. Last question for this graph, friends. What's the dependent variable? D is dependent because the distance that we travel is dependent upon the time that we drive, so time is our independent variable. Okay, let's work one more example together before I have you try one on your own. Let's take a look at our next example. A car uses 1 gallon of gas for every 20 miles traveled. The amount of gas left in the gas tank, X gallons, after traveling Y miles, is given by Y equals 240 minus 20X. Complete this table, then graph the relationship between X and Y. use 1 unit on the horizontal axis to represent 1 gallon, and 1 unit on the vertical axis to represent 20 miles. Okay, so let's begin by completing the table. We can see that if we have 12 gallons of gas in our tank, we've gone 0 miles. The capacity of our gas tank is 12 gallons. So when it's full, when we've gone 0 miles, we've got 12 gallons of gas. If we have used 2 gallons of gas, meaning we have 10 gallons left, that means we've traveled 40 miles, correct? Because 1 gallon of gas is consumed for every 20 miles that we travel. Next, if we've gone 80 miles, how many gallons of gas will we have in our tank? That's right, we'll have 8. We'll have gone another 40 miles using 2 more gallons of gas. So we'll have gone from 10 gallons to 8 gallons. The next relationship we see is that if there are 6 gallons of gas left in the car's tank, we've gone 120 miles. Finally, after we travel another 40 miles to have a grand total of 160 miles, that means we must have only 4 gallons left in our tank. Okay? Now, let's go to the next step, which is graphing our gas consumption. Referring back to the question, we were asked to graph using 1 unit on the horizontal axis to represent 1 gallon and 1 unit on the vertical axis to represent 20 miles. Okay, I'm actually going to hand draw this graph just so you can see the technique that I use when I'm trying to quickly complete a graph. I know that everything I'm about to graph is going to be in quadrant 1 because both of my numbers are going to be positive. So I'm just drawing this very abbreviated version of the coordinate plane. I'm using 1 unit on the horizontal axis to represent 1 gallon of gas. So let's quickly put those into place. With this being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And each mark on my y-axis is to represent 20 miles. So this will be 20, 40, 60, 80, 100, 120, 140, 160, and 180. Okay, now let's graph our relationships. Our first relationship tells us that the amount of gas equaling 12 means that we've gone 0 miles. So our ordered pair is 12, 0, and we're going to put a dot right here to show that point. Next up, if we have 10 gallons of gas, that means that we have traveled for 40 miles. That's going to go right about here. And if we've gone 80 miles, then we have about 8 gallons of gas in our tank, which should be about right here. Then if we have 6 gallons of gas in our tank, we've probably gone about 120 miles. So that's going to be right around here. It's not perfect, that's okay. And at 4 gallons of gas, we've traveled 160 miles. Okay, there we go. Oops. You can see it's not totally perfect. That is okay. It gives us the basic idea. Now connect these lines, and that gives us our linear graph or our straight line graph. Okay, so let's go on to the next question here, which is using this graph now to answer information that isn't given on our table. The first question is, how many gallons of gas will be left in the tank after the car has traveled 60 miles? This is a simple question to answer simply by using our graph. We go up to our 60 miles line. We're going to draw a line over to our graph. And we're going to drop that line down to our x-axis where we can see that if we've traveled 60 miles, then we should have 9 gallons left in our tank. Okay? Next up, how many gallons of gas will be left in the tank after the car has traveled 100 miles? Follow the same procedure. Start at the 100 miles mark and drop it down. And there we can see that for 100 miles traveled, we're going to have 7 gallons left in our tank. Okay? After the car has gone 160 miles, how much farther can the car travel before it runs out of gas? Interesting question. So for every gallon used, the car travels 20 miles, right? So distance is going to equal the number of gallons times the mileage. Remember, mileage is a rate. Our rate is 20 miles per gallon. So the gallons used will be 4, or the gallons left will be 4, right? Because when we've gone 160 miles, we have 4 gallons of gas left. We can go 20 miles to the gallon, so we can travel another 80 miles before we run out of gas. All right, last question. If the car travels more than 40 miles, so if the car goes 40 miles or more, how much gas is left in the tank? Good question. So let's follow this over to our line. That means there is going to be less than 10 gallons left, right? If we've gone 40 miles, then our X, which is the number of gallons in the tank, has to be less than 10. Because remember, the question asked if the car travels more than 40 miles, how much gas is left? Well, it'll have to be less than 10 gallons because our 40 miles of travel uses 2 gallons of gas. So out of our 12-gallon tank, we have to have less than 10 gallons left. Make sense? Okay. Our dependent variable then would be Y, the number of miles traveled. Our independent variable then would be X, the amount of gas in the tank. All right, let's try one of these on your own now that we've worked through 2 examples pretty extensively. And here's your practice problem. Sarah plants a seed. After T weeks, the height of the plant, H centimeters, is given by H equals 2T. Complete the table below. Graph the relationship between T and H. Use 1 unit on the horizontal axis to represent 1 week. So 1 unit equals 1 week on your x-axis. And 1 unit on your y-axis is going to equal 2 centimeters. Okay? So follow those rules when you make your graph, okay? Then answer the following questions. Okay, so first thing, graph the relationship. Question 2, what type of graph is this? Question 3, what is the plant's height after 3 weeks? Question 4, what is the height after 5 weeks? And finally, what is the height if less than 4 weeks have passed? Express this as an inequality. Don't forget to label your dependent variable and your independent variable. All right, folks, that wraps up practice 9.3 for the video. When I see you tomorrow, we'll do several more problems like this together to seal this information into your brains. Have a great evening, and I'll see you tomorrow.